Good morning, dear students. Again, we are here to discuss some topics on mechanics of materials 2. In the last class, we have discussed some problem related to principal stress and how to find the direction cosine of that principal stress. So today again, we shall do some more examples so that we can better understand the concepts. Let's see. So for the given stress, we have to determine the principal stress and their direction. And the stress matrix is like this, as you can see on the screen. So this is our stress matrix. So as I have told you earlier, there are certain steps we need to follow to find the principal stress and their direction. Let's recall those steps. Those steps are, first of all, we need to form a cubic equation. In order to form the cubic equation, we need to calculate L1, L2, and L3. L1, L2, and L3 are the stress invariants. Means the value does not change even after changing the frame of reference or the coordinate system. Then after forming the cubic equation, we need to find the roots of that cubic equation. And these roots are called as the principal stresses. Once the principal stresses have been calculated, then after we need to find the direction cosine associated with those principal stresses. This is what we are asked in this example. Let's see how we can do. First, our task is to calculate L1, L2, and L3. In order to calculate L1, L2, and L3, it is based on a certain formula, which will include the value of sigma x, sigma y, sigma z, tau xy, tau yz, and tau zx, the 6 rectangular stress component. For that, we need to compare the given matrix, means this matrix, with the stress components. So let's see how we can compare. We need to compare this matrix with this matrix in order to get the values of sigma x, tau xy, and tau zx. There you can see that this sigma x is equal to 0. That is mentioned here. Tau xy is equal to 1. That is written here. Tau zx is equal to again 1. So that is equal to 1. Tau xy already we have calculated, it is equal to 1. Sigma y is equal to 0. That is mentioned here. And sigma z is equal to 0. That is again mentioned here. And tau yz is equal to 1. That is taken from here. So in this way, all the stress components have been written. Once the strain components have been written or identified, then we need to find out the value of L1, L2, and L3. So for that, let's start with L1. So L1 can be calculated by adding sigma x plus sigma y plus sigma z, as the value of sigma x, sigma y, and sigma z all are 0. That's why L1 should be equal to 0. So in this way, L1 has been calculated. Next task is to find out L2 and L3. So in next slide, I have written all the results that we have calculated so far. Then after moving for our next step, that L2, how to calculate L2. For L2, the formula is like this. L2 is equal to sigma x into sigma y plus sigma y into sigma z, and like this we will use this expression. For that, we have the value of sigma x equal to 0, sigma y equal to 0, sigma z we have the value. So simply substituting the value, one can get the value of L2. So the value of L2 comes equal to -3. That has been highlighted as a result. Now, next task is to calculate the value of L3. L3 can be calculated by the expanding the determinant, the stress determinant as it was given in the question. So this is our determinant, we need to expand it. So for that we need to multiply this 0 with its cofactor, that is 0 into 0, obviously 0 minus 1. So 0 multiplied by anything would be equal to 0. The second is to 1. Minus 1 should be multiplied with minus 1 should be multiplied with 1 into 0 into 1 into minus 1. 1 into 0 to 0 and then after minus 1. So minus 1 it should be equal to plus. Similarly, we need to multiply with its cofactor. So the result is like this. 0 then after minus 1 multiplied by minus 1 and 1 multiplied by its cofactor and the result is 2. So once L1, L2 and L3 has been calculated, now we need to form the equation. So for this, for forming the cubic equation, we should go by the standard format. That is Q F sigma equal to sigma cube minus L1 sigma square plus L2 sigma minus L3. So we only need to put the value of L1, L2 and L3. And value of L1 and L2, L1, L2 and L3 are shown in blue color, like this. So after substituting the value, the cubic equation is like this. Now next task is to solve this equation. It can be simplified by simple mathematics. The next step, we have multiplied minus on both right hand side as well as left hand side. So now this 2 has been written as minus sigma q minus 1, and with little bit of adjustment we have written it like this, 3 sigma plus 1. Then if I take minus from here as a common, then we can write it as sigma q plus 1 and this will be written as it is, like this. Then since sigma q plus 1 is in the form of a cube plus b cube, and the formula of a cube plus b cube is a plus b into a square minus ab plus b square, like this. This has been written here, a plus b into a square minus ab plus b square. And from here we can take common is equal to sigma plus 1. So sigma plus 1 and sigma plus 1 can be taken as a common from both of these two expressions. So in the next step, let's see what comes. Sigma 1 is taken as a common. So then after we are left with sigma square minus sigma plus 1, and here we will be left with 3. So on simplifying it, we can get a result like this. This will result as a root sigma 1 is equal to minus 1 from here and minus 1 from here, and sigma 3 is equal to 2. So we have the principal stresses as minus 1, and 2. The first two roots are equal, and third root or the third principal stress is different. So our next task is to find out the direction cosine, and obviously we will start from sigma 3 is equal to 2, that I have written here. Since two of the three principal stresses are equal and sigma 3 is different, that's why every direction perpendicular to sigma 3 is a principal direction associated with sigma 1 and sigma 2. So we will start with sigma 3 equal to 2 to find the direction cosine. Let's see how we can calculate. Again, the results have been written here. Sigma 1 equal to sigma 2 is equal to minus 1 and sigma 3 is equal to 2 from the last slide. So for sigma 3 is equal to 2, in order to calculate the direction cosine, we used to go back the basic mathematical equation that we have find while deriving the principal stress and principal stress condition. Those equations were like this. In this equation, we need to put the value of sigma x and sigma, then after tau xy and tau xz. So sigma x is equal to 0. So once we put it the 0 and sigma 3 is equal to 2, so it would become minus 2 nx, minus 2 times nx. Then after tau xy it was equal to 1. So we can write it as ny. Again tau xz is equal to 1. So it can be written as nz is equal to 0. So this is our first equation. So similarly, we can get all the three equations. Equation first, equation 1, equation 2 and equation 3 by putting the value of tau xy, sigma y and tau yz. Similarly, tau xz, tau yz and sigma, we can get these three equations. So we have three unknowns, nx, ny and nz are three unknowns, and we have the three equations. So it is quite easier to find out the value of nx, ny and nz. And we have one more condition, that is the condition of non-trivial solution. That is nx square plus ny square plus nz square is equal to 1. So with the help of these four equations, we can get the value of nx, ny and nz. Let's see how we can do. So for the first result, let's subtract equation 1 minus equation 2 so that this nz can be cancelled out. So equation 1 minus equation 2 results in nx equal to ny. If these two are cancelled out, so you can get this result. Now from equation 2 and 3, if we subtract equation 2 from equation 3, this nx would be cancelled out. And as a result, we can get like this, ny is equal to nz. So now we are nx equal to ny and ny is equal to nz. So we have to use this condition in the condition of non-trivial solution. That was like this, as I have told you earlier. So by putting the value of nx equal to ny equal to nz, we get a result like this, nx equal to ny equal to nz equal to 1 by root 3. So this is the direction of the plane associated with this sigma 3 is equal to 2. This is the direction cosine associated with this. So here sigma 3 is equal to 2 in the direction of 1 by root 3, 1 by root 3 and 1 by root 3. So in this way we have seen that how we can find out the principal stress and principal strain. So these are two important examples from the exam point of view and also to make you understand better about the concepts. So this was all for today. Thank you.